Welcome back to Technique Professors. So let's start. Hello everyone, welcome back to Technical Professor. So in this lecture, we are going to discuss about data structures. So data structure for beginners. Also, data structures are one of the most important topics in computer science. They help us organize, store, and manage data efficiently. So in this lecture, we will understand both concepts and practical code examples step by step. So let's start it. So let's start it. So So let's begin with agenda. So we will start with introduction to data structures that explore their types and classifications. Types and classification. Classification. After that, we will study core data structures along with code examples. So finally, we will discuss complexities and real world applications. All right. So now let's start it. So before starting that, first of all, I have to introduce myself. So I'm a data science student at Delhi Technical University with experience in teaching programming and data structures. So I have worked with platforms like Nalit and Microsoft. So I'm passionate about simplifying complex concepts and helping beginners that I'm want to a, able to student build strong foundation. So let's start it. So what are the introduction to data structures? So let's start it. So data structure is a method of organizing and storing data efficiently, and they allow us to perform operation like searching and insertion and deleting data quickly. Okay, so I have to write it. Inserting, deleting quickly. So without data structure, writing efficiently program would be very difficult. So there are the foundation of all algorithm that is used in real world application. Okay, so now we are going to understand what is the importance there, why are data structure important. So they improve performances by reducing time and memory uses. For example, efficient data structures can make data up to 50% faster. So and they help in building scalable system that handle large amount of data efficiently. Okay. So now before starting that, we are going to learn about terminology. So, so before moving ahead, let's understand some basic terms. So data refers to the value we store. An element is a single piece of data. Okay. What is data there? Which, oh, that's fine. It's all there. What is data there? That refers to the value we store. And element, what is element there? Single piece of data. And what is node? It is a structure that store data and link to other elements. So understanding these terms help us to build a strong foundation. All right. So now we are going to understand what data structure classification, understanding linear and non-linear data structure. So, so data structure are broadly divided into two types. First one is linear, and second one is non-linear. In linear data structure, data is stored elements in a sequential manner, like array, linked list, and in non-linear, like tree, graph. So choosing the right type depend on the problem we are solving. Okay. So now first we are going to learn about arrays. So arrays and arrays store element in contiguous memory allocation like that. You can see like we will store data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this way, contiguous memory allocation. This means all elements are placed next to each other in memory. Because of this, array provide fast accessing using index position. However, they have fixed size which limit flexibility. Okay. So now we are going to understand array code. So let's look at this code example. We will create a list array with values 10, 20, 30, and 40. Okay. We will access element using index where index starts from 0. Okay. If we want to access the like 0, 1, 2, 3. In this way, we are doing indexing. So if we want to access uh, first index element, we have to print array 1, that the output will be 20. Okay. We insert a new element using append or like remove an element using remove. Okay. So this show how arrays easily access and basic operation. Okay. So now next we are going to understand linked list. So linked list is very important data structure. So English a linked list is different from arrays. Instead of storing elements in contiguous memory, it uses node connected by pointers. Okay. So each node contains data and reference to next node. So this allow dynamic memory allocation and flexibility data handling. Okay. Now we are going to understand this code. So you can see that in this code, we define a node class. Each node store data and pointer to the next node. We will create two nodes and link them together. Okay. You can see first we will create node 10, second 20, and we will then we traverse the list using a loop to print each elements. So this demonstrates how linked list work internally. Okay. Then this is the code for traverse. Like we will store into m into head, then we will print this linked list. Okay. So now we are going to understand stack data structure. So stack follow the last in first out. We can say ref also. Okay. Last in first out. This means the last element added is the first one remove. You can think of like a stack of plates. Stacks are commonly used in recursion and undo operations. Okay. And stack is a fundamental data structure that operates on the principle of loss in, lost out, allowing efficiently data management for various application. Okay. So now we are going to understand queue. So a queue follows the first in, first out principle. This means the first element is added to the first one we removed. This is similar to a line of people waiting for a service. For example, you are going to buy a ticket and buy uh, doing a motorcycle service and car service. This is the example of queue. Okay. So this is the code for queue. Here we use DQ from collections. First we will import from collection import DQ. Then we will append element to the rear of the queue. Then pop left remove element from the front. So this make queue operation efficient and suitable for scheduling system. Alright. So now we are going to understand about tree structure. So a tree is a hierarchical data structure. It consists of root node and child node. And each node can have multiple children. For example, like this is root, these are childs. Okay. And tree are widely used in file system databases. Okay. So you can implement this for using code also. So in this code, we define a node class from tree. Okay. And each node has left and right children. And we will create a root node and assign child nodes. So this form of basically a binary tree structure. Okay. So now we are going to understand about graph networks. So a graph consists of nodes and edges. It is used to represent relationship between different identities. So example, it includes social networks and maps. It is used in like Google Maps also. All right. So it have edges and weight. Okay. So now we are going to understand graph code. So graph is implemented using an adjacent list. So each node maps to connect to the connected nodes. I can draw diagrams like that. In this way, we implement code. So each node connected to its connected node. Each node maps to its connected nodes. We will perform BFS traversal using a queue. This allows us to visit node level by level efficiently. Okay. So now we are going to understand about time complexity. So time complexity measures how fast an algorithm runs. We use big of notation like order of one, order of n, order of log n. So it helps us to compare different solutions and choosing the most efficient one. Okay. Now we are going to understand about space complexity. Space complexity measures memory uses. It includes both input space and extra memory for use by algorithm. So balancing time and space is very important for optimal performance. So now comparison arrays work versus linked list. So I will write there array. Faster array provide faster access but limited flexibility. There is not flexibility there in array. In linked list, it is allowing easily insertion but slower access. Choosing the right structure depend on your needs. Okay. So what are application of data structures? So data structure are used in very many real world applications. There are used in databases like that. There's a database, operating system, and networking and artificial intelligence. So they help manage and process data efficiently. All right. So what are the best practice? So to use data structure effectively, always choose the right one for your program. Keep your code simple and efficiently, and most important, practice regularly. Okay. So conclusion is, to conclude, data structure are the fundamental program part of programming. They help us write efficiently and stable program, build strong fundamentals, and practice coding and move forward to learning algorithm. Thank you so much for watching this video. Make sure subscribe my channel and share to everyone who are learning data structure. Thank you so much.